Dear students, Salam Alaikum. Today we shall have topic 11 Integration of powers of trigonometric functions in Calculus 2 Math 200. In this topic we shall consider integrals of the type sin power m ax into cos power n ax, where m and n are natural numbers 1, 2, 3, 4, 5, and we'll have ax as the argument for both of them. If it is ax here and bx here, we have to use some other technique which we shall do some other time. Now we'll be needing three algebraic identities which are a plus or minus b whole square equal to a square plus or minus 2ab plus b square, a square minus b square equal to a minus b into a plus b, a plus or minus b whole cube equal to a cube plus or minus 3a square b plus 3ab square plus or minus b cube. We'll be needing the three basic trigonometric identities: sine square a plus cos square a equal to 1, secant square a minus tan square a equal to 1, cosecant square a minus cot square a equal to 1. These identities can be written in different ways. For example, the first identity you can write as sine square equal to 1 minus cosine square, or you can write cosine square equal to 1 minus sine square. You can interchange the position from left to the right and change the sign accordingly. Now these were the first three basic identities from your triangle trigonometry from the school. Then we have the double angle identities. Now sine square a equal to half of bracket 1 minus cos 2a, cos square a equal to half of bracket 1 plus cos 2a, and 2 sine a cos a equal to sine 2a. So frequently we'll be using these identities which I have read out to you. In one question we might need 2 or 3 of these identities. Now there is one integration rule which we'll be using frequently in this along with the others which we have used. I am writing this for completeness. Integral u power n du equal to 1 over n plus 1 u power n plus 1 plus c. N not equal to minus 1. When n equal to minus 1 we use the natural logarithm. So we have seen this formula before. I just wrote it here as a reminder. Now we are going to consider integrations of the type sin power m cos power n. Now m can be odd or even, n can be odd and even, and there are three cases which are useful to us. Case 1, if m is odd, then n can be either odd or even, it does not matter. Then we write sin power m as sin power 2k, the even part, plus 1. The odd number is even plus 1. So you can now how much is sine? This can be written as sine square whole power k into sine ax into cos power n ax. So we'll be operating only on the sine. In this case, it is 1 minus cos square ax whole power k into sine ax. Now, this is like our previous topic. We have to use substitution. The derivative of cosine is minus sine with the number a, minus a sine ax. Now you have the function here, and the derivative is sitting here. So now we can integrate this using the substitution u equal to cos ax with du by dx equal to minus a sine ax and sine ax dx equal to minus 1 by a. When you make this substitution, your integral of this will become minus 1 over a integral u power n into 1 minus u square whole power k. Now we have to open the bracket here, 1 minus u square whole power k, using the basic identities. If k is big, then it will take more time. If k is small, then it will be a smaller question. And this we know how to integrate. And once the integration is over, we'll put back u equal to cosine ax. Now if m is even and n is odd, again we do a similar substitution. We write sine power m ax. We do not do anything to it. We just open the odd part. Cos power 2k plus 1 into a power x, because any odd number can be written as n equal to 2k plus 1, where n is odd. and k can be either odd or even. Now it will become cos square ax whole power k. This you convert into sine, you'll get 1 minus sine square ax whole power k. Now here you have a function in sine and the derivative of sine is cosine with the a. So you'll again make it into an algebraic integral. It is using the substitution u equal to sine ax, and your integral becomes 1 over a u power m into 1 minus u square whole power k. These substitutions will help you to convert your trigonometric integrals of this type to algebraic integrals. And these algebraic integrals we have seen, if k equal to 1, 2 or 3 or 4, we can use the identities which we have on page 1 and do it. Even if k is big, we have to do the same thing. But normally in simple examples, we'll have simple values of k like 1, 2, 3, and it will not be very difficult to open the bracket. If one is now in the case 1 and case 2, one has to be odd, the other can be either odd or even, it really does not matter. Now one is even and one is odd. Listen, let me repeat. In case 1, one is even, the other can be even or odd. In case 1, one is even and the other is odd. Now if both are even, you have the case 3. Case 3, when both are even. When both are even, you have to use the double angle identity sine squared a equal to half of 1 minus cos 2a, cos square a equal to half of 1 plus cos 2a. So just to summarize, in case 1 and case 2, one of them has to be odd, and in case 3, both have to be even. Then you can use the double angle identities and we'll see numerical examples shortly. Like problem 1, evaluate sine cube 4x into cos square x 4x. See, the argument is same in both, so we have to follow the method we have. Now this sine cube can be written as sine square into sine. Cos square, leave it as it is. Convert this sine square into 1 minus cos square. So what do you have? You have 1 minus cos square here and cos square. Derivative of cosine is minus sine with the number which is 4 in this case. So make the substitution u equal to cosine 4x. Now you will get u square into 1 minus u square bracket. Now how much is dx? Now sine 4x dx is minus 1 over 4 du. So you will get u square into 1 minus u square into bracket minus 1 over 4 du. Now you can absorb the minus in this bracket. Take the u square inside, you will get u power 4 minus u square du, 1 over 4 outside. We have to remember that we have to convert the full integrand with the dx along with dx into u, and sine 4x dx after substitution is minus 1 over 4 du. We have done certain types of substitutions before, so I will not go into more detail about the substitution. The main idea is more important. These working details we have seen before. Now this is u power 4 minus u square. Now this integral u power n occurs very frequently, so we have to keep using it. We'll get u power 5 over 5 minus u cube over 3. Now 1 over 4 is outside, your integration is over here. Now you can factorize this if you so wish and put back the value of u. When you factorize, you'll get 1 over 60 into u cube into bracket 3u square minus 5. Now u equal to cosine 4x, put back the value of u, and your answer is complete in all respects with plus c. Now what we have used in this, we have used this integration rule, u power n du. We have used sine square a plus cos square a equal to 1, only the first identity. We have not used any of the other identities in this question. Then you can differentiate and check the answer. We have done this many times before, so we will not go into more details. Now evaluate cos power 5. Now what happens in this kind of question, even if you don't remember the cases per se exactly, this cos power 5 is 4 plus 1, you'll get cos power 4 plus 1. You have cos power 4 into cos power 1. 3x will remain there. We don't have to talk about it at this stage. Now this cosine power 4 has to be converted into sine. As a function of sine, and derivative of sine is cosine with the number. So now cos power 4 can be written as cos square whole square. Now cos square is 1 minus sine square. So you'll get 1 minus sine square whole square into cosine. Derivative of sine is cosine with the number. So you have a function whose argument's derivative is available. So you can again do it. You'll get 1 minus sine square whole square into cos 3x dx. Now make the substitution. U equal to sine 3x. You'll get du by dx equal to 3 cos 3x and cos 3x dx equal to 1 by 3 du. So you'll get 1 minus u square whole square into 1 by 3 du, because we have to convert both the function and the dx also. You'll get 1 over 3 du. Now open this bracket using one of the identities on page 1. You'll get u power 4 minus 2u square plus 1. Imagine if the power was big, then you'll have more terms after opening the bracket. Now we are basically using the binomial expansion here. This is 1 over 5. Now you integrate it. You'll get 1 over 5 u power 5 minus 2 over 3 u cube plus u plus c. Now you can take a common this thing. 15 inside the bracket, 3 is outside. You'll get 45. Inside the bracket you'll get 3 u power 5 minus 10 u cube plus 15 u plus c. How much is u? U equal to sine 3x. So substitute it back and your answer is complete in all respects. So what did we use in this answer? We use this formula u power n du. Then we use a minus b whole square. Then we use the identity sine square a plus cos square a equal to 1. And you can check your answer by differentiation. I don't have to go into more detail about differentiation. We have seen it in all our previous chapters. So I will leave it in this chapter. Now we have done the question for cos power 5. The question for sine power 5 is very similar, but we'll go through it very rapidly. Sine power 5 is equal to sine power 4 plus 1. Now you have sine power 4 into sine. Now derivative of cosine is minus sine with the number. Now this sine power 4 has to be converted into cos by using the identities. So sine power 4 is sine square square. You'll get 1 minus cos square whole square. Now put the substitution u equal to cosine 6x. You'll get sine 6x dx equal to minus 1 by 6 du. Now start substitution. You'll get 1 minus u square whole square into bracket minus 1 over 6 du. You have to be very careful about the plus minus signs in this type of questions when you make the substitution. Now this minus 1 by 6 will come out. When you square this like last time, you'll get u power 4 minus 2u square plus 1. Integrate it, you'll get 1 by 5 u power 5 minus 2 by 3 u cube plus u. You can take 15 common, and 15 into 6 is 90, and the minus is outside. You'll get minus 1 over 90, 3 into u power 5 minus 10 u cube plus 15 u plus c. Now put back the value of u equal to cosine 6x, and your answer is complete after you put back the value of the substitution which you had used. Now what are the rules we have used? We have used the rule u power n du. We have used the identity a minus b whole square, and we have used the identity sine square a plus cos square a equal to 1. And again the answer can be checked by differentiation. Next is evaluate cosine square 7x. Now this is your first question with an even power. Whenever you have an even power in both, there is no sign here. So don't look for the sign. You can directly do the cosine square. We have done it before in another chapter by using the same idea. Now cosine square, you have to use the double identity. Whenever you have an even power, think about the double identity. So the double identity is cos square, double angle identity. Cos square a equal to half of 1 plus cosine 2a. Now cosine square 7x will become half of 1 plus cosine 14x. See, you are trying to get rid of the power 2, at the expense of doubling the angle. We'll be using this formula. Now integration of cosine square will be half of 1 plus cosine 14x. It is 7x here, it is 14x here, the angle doubles. Now this integration we have done many times before, this kind. The half will go out, you will get 1 plus cosine, 1 is separate, cosine is separate. Integrate, integration of 1 is x, integration of cosine is sine divided by the number. It is plus sine divided by the number, so it is x plus 1 over 14 sine 14x. Now plus c. Now your answer is complete here, the integration is over here, but since the question is given in the angle is 7x in the question, so you should make it 7x here preferably. So sine 14x equal to 2 sine 7x cosine 7x. Now this 2 will cancel with the 14, you will get 1 over 7. So x plus 1 by 7 sine 7x plus cos 7x. See, no more trigonometry can be done on this, so we can just leave it as it is. What are the rules which we have used here? Only one rule has been used. Integration of cosine is 1 over k sine kx plus c. Remember to divide with k, and again the answer can be checked by differentiation. Now evaluate sine square 9x. This question is just like the last question. Only thing is, last time you converted cos square into double angle. Now here you are going to convert sine square into double angle. Now what's the double angle identity? Sine square equal to half of 1 minus cos 2a. Last time it was cos square a and the identity was 1 plus cos 2a. Now it is 1 minus cos 2a. So sine square 9x equal to half of 1 minus cosine. Double the angle, 9 into 2 is 18. You have 18x here. Now put it in the integration. Integration of 1 is x and integration of cosine is plus sine divided by the number, and the number is 18 here. So it is half into x bracket x minus 1 by 18 sine 18x. Now again you can argue that the question was given in 9x, so let's switch over to 9x. You'll get 2 sine 9x into cosine 9x. This 2 will cancel with 1 over 18 and you'll get 1 over 9, and the minus sign is of course there. This is it. And what rule did we use? Integration of cosine is plus sine divided by the argument number in the argument, and it is 18 in this question. It can be different in other questions. Now evaluate cosine cube 5x. Now cosine cube is cos power 2 plus 1, which is cos square is separate into cosine x. Now this cosine square has to be converted into sine. You'll get 1 minus sine square bracket into cosine. Now you have to make a substitution because the derivative of sine is cosine with the number. So you put u equal to sine 5x and cosine 5x dx is 1 over 5 du. Now when you substitute, you'll get 1 minus u square into 1 over 5 du. 1 over 5 will come out. Now this question is easier than the last question. You don't have to do any binomial expansion. It is integral 1 over 5. Inside you have 1 minus u square du. The answer is u minus 1 over 3 u cube. You can take 3 up and you will get 3u minus u cube divided by 5 into 3, which is 15. Now put back the value. How much is u? Look at your substitution. It is sine 5x. So you'll get 3 sine 5x minus sine cube 5x in bracket into 1 over 15 plus c. Now we have to use, what are the rules which we have used? We have used only the same rules. U power n du equal to 1 over n plus 1, u power n plus 1, and the identity is sine square a plus cos square a. Just remember that we have to use the identities on page 1 repeatedly, not all of them, just some of them. You can do many questions using these identities. Only thing is the algebra will differ slightly, but the idea is the same and it can be carried forward. Now same thing happens for sine cube. We have integrated cosine cube. Now let's integrate sine cube. Now you'll get, this is an odd, sine cube is sine square into sine. Now derivative of cosine is minus sine, so we have to convert this sine square into cosine. As a function of cosine, sine square is 1 minus cosine square. We'll get 1 minus cosine square 9x bracket into sine 9x. Now derivative of cosine is minus sign with the number. That number and the minus sign can be adjusted. So you put u equal to cosine 9x and sine 9x dx is minus 1 over 9 du. Now after substitution you'll get 1 minus u square. This minus 1 over 9 is outside. Now this can be integrated. You'll get u minus 1 over 3u cube and you'll get 3u minus u cube. Take the minus sign inside, you'll get u cube minus 3u. Put back the value of u, it is cosine 9x. Your answer is over here, and 9 into 3 is 27. You can see it yourself. The answers for sine cube and cosine cube are very similar. They are different but similar. The steps are also similar. Again, you can differentiate and check the answer. Now let's look at this question. Evaluate sine square 5x into cosine square 5x. Now both are even, so it is case number 3. Now we have to use the double angle identities. What are the double angle identities which I have written? One for sine square, one for cosine square. Both are sine square is half of 1 minus cos 2a and cosine square is half of 1 plus cos 2a. Now let's do the algebra without writing the integral symbol repeatedly. Now sine square 5x into cosine square 5x will be half of 1 bracket 1 minus cos 10 into half of bracket 1 plus cos 10. 1 is for sine square, 1 is for cosine square. Half into half is 1 by 4, 1 minus cos into 1 plus cos. Now use the algebraic identity, it will become 1 minus cosine square. Now 1 minus cosine square, do not convert it into sine square. Cosine square is half of 1 plus cos, double the angle. So first time when you double, 5x became 10x. Again you double, it will become 20x. Now you have 1 minus half cosine 20x. This is half minus cosine 20x. Take this half outside. 1 by 4 into 1 by 2 is 1 by 8. So this sine square, cos square has been converted into an expression which we know to integrate. Now which identity did we use in the algebra? A minus b into a plus b is a square minus b square with a equal to 1 and b equal to cosine 10x. Now we can do the integration. It is 1 over 8, 1 minus cos 20x. 1 over 8 will go outside the integration. You have 1 minus cos 20x. Now integrate. Integration of 1 is x. Integration of cosine is plus sine divided by what is the number inside? 20. So integration is x minus 1 over 20 sine 20x plus c. Now we can convert this into 10x if we so wish. And again we can do some algebra to convert it into 5x using the double angle identities. But the basic answer is over here at 1 over 8 x minus 1 over 20 sine 20x plus c. So this is it. The answer can be differentiated and checked. Next question. Evaluate sine square 3x into cosine power 4 3x. Now again both are even, so we have to use the double angle identities. Now sine square will be 1 minus cosine 6, double the angle is 3 into 2 is 6. Now the next bracket is half of 1 plus cosine 6x whole square. Because you have cos power 4 is cos square whole power 2. Now whole square also you can say. Now half into 1 minus cos 6x into this. Now expand this bracket, you will get 1 plus 2 cosine 6x plus cosine square 6x. Now the first bracket now you multiply the two brackets, you will get 1 over 8 bracket 1 plus cos 6x minus cosine square 6x minus cosine cube 6x. So we have to multiply the two brackets and then do anything. Please do not convert this cosine square into double angle because you'll have 12x here and 6x in the other bracket and it will lead to difficulties. It can be done that way, but better to do it this way. Now it is 1 over 8, 1 plus cos 6x minus cosine square 6x minus cosine cube 6x. Now this cosine square you can convert into double angle. So you'll get half into 1 plus cosine 12x. minus 1 over 8 cosine cube 6x. Now the first three terms we know how to integrate. The cosine cube we have done before, so we have to use a substitution, which I am showing it here at the end of the page. Cosine cube integration will be 1 by 6 sine 6x minus 1 by 18 sine cube 6x plus c. We do not need this plus c, I have written it for completeness. So cosine cube we have done before, so just do it like before, and the remaining three things we have to do now. You will get 1 by 16x plus 1 by 48 sine 6x minus 1 by 192 into sine 12x. Now how do you get these numbers? Look, when you did your manipulations on your trigonometric function, you had 1 over 16 plus 1 over 8 cosine 6x minus 1 over 16 cosine 12x minus 1 over 8 cos cube 6x. The cos cube 6x we have seen before, so just do it like before, done at the end of the page. Now the remaining things you have to do directly here. You'll get 1 by 16x. Integration of cosine is sine. 8 into 6 is 48. Integration of cosine is again plus sine divided by 12. 16 into 12 is 192. You get it here, and this cosine cube part you copy from there. Then you'll get these two terms. Now combine. Sine 6x is coming here, sine 6x is coming here. It will get cancelled. 1 over 48 minus 1 over 48. Then you are left with 1 over 16x minus 1 over 92 sine 12x plus 1 over 44 sine cube 6x. If somebody wants, they can convert this sine 12x into sine 6x to sine 6x cos 6x. There's no need, so we are not doing it. We can leave the answer at this. And again, the answer can be checked by substitution. Now we have a new type of question. Integrate tan power 4 3x dx. Now we are going to use this identity, secant square minus tan square a equal to 1, which means tan square a equal to secant square a minus 1. You can take the tan square on the right and 1 on the left. You will get tan square a equal to secant square a minus 1. Now tan power 4 is tan power 2 plus 2, which is tan square into tan square. The argument remains the same. Tan square 3x into secant. Now this tan square you convert into secant square 3x minus 1. Now you open the bracket, you have tan square into secant square. What's the derivative of tangent? Derivative of tangent is secant square with the number. Now you have tan square secant square here, and here you have tan square alone. Minus tan square actually. So you will write it as minus bracket secant square minus 1. So your final thing is tan square 3x into secant square 3x minus secant square 3x plus 1. Now we know how to integrate secant square. We are going to get the tangent. If you integrate 1, you will get x. Now this tan square secant square, derivative of tangent is secant square with the number. So you have to do substitution. You will get u equal to tan 3x, and your answer will be tan power 3 divided by 3 and one more number. So let's see the substitution. U equal to tan 3x, du equal to 3 secant square 3x dx. Remember, derivative of tangent is secant square. So secant square 3x dx is 1 over 3 du. Now take tan square into secant square dx. You will get u power 2 into 1 by 3 du, which is integral 1 by 3 will come out. Integration of u square is u cube by 3. So finally you'll have 1 over 9 u cube, which is 1 over 9 tan cube 3x. So we have fixed the number, and tan cube we had guessed. Plus c. Not guessed actually, we had seen it. Now this c is not really needed in the middle step. So now your integration of tan power 4 will be 1 minus secant square plus tan square into secant square. Integration of 1 is x, integration of secant square is tangent divided by the number inside, which is 3, and the last part, which is tan square secant square, we have seen it here just by the substitution. So this is your answer. X minus 1 over 3 tan 3x plus 1 over 9 tan cube 3x. If you want, you can take the 9 common, but it's not really necessary, so we'll not do it. and you can check your answer by differentiation. Now this question is easier than the last question. Evaluate tan cube 13x secant square 13x. Now what's the derivative of tangent? It is secant square with the number gets adjusted. So your answer will be with substitution, and it will be tan power 4 divided by 4 and another number which is inside. So you can see it, put u equal to tan 13x, du equal to 13 secant square 13x dx. Then secant square 13x dx equal to 1 over 13 du. Now let's look at the integration. Tan cube 13x into secant square. Now we have to make this substitution. You'll get u cube into 1 over 13 du. 1 over 13 will come out. The integration of u cube is 1 over 13 into, integration of u cube is 1 over 4 u power 4. 13 into 4 is 52. So you'll get 1 over 52 u power 4. And how much is u? U equal to tangent 13x. Just put it back, we have to get it. So what that number 1 over 52 had to be fixed by writing. We had seen that the answer is tan power 4 divided by 4 and the 13 is inside. So you can write little bit less and do this question with less writing also. And the answer can be checked by differentiation as before. Now next is question is evaluate the integral tan 6x secant power 4 6x. Now just try to guess and try to remember. Derivative of secant is secant x into tan x. So this secant power 4 can be written as secant power 3 into secant x tan x. Now the derivative of secant is secant into tangent and there will be a number. That number will get fixed. So your answer will be through substitution and put u equal to secant 6x. So du equal to 6 secant 6x tan x. Secant into tangent dx equal to 1 over 6 du. The arguments are not going to change, so I am not reading them. So you can write it as u power 3 u cube 1 over 6 du. 1 over 6 will come out. Integration of u cube is 1 over 4 u power 4. 6 into 4 is 24. You have 1 over 24 u power 4. How much is u? Secant power 6. Sorry, secant 6x, not power. So u equal to secant. So your final answer is 1 over 24 into secant power 4 6x plus c. Now again we have used the same old rule, u power n du equal to 1 over n plus 1 u power n plus 1. Now you can again check the answer by differentiation. And what identity did we use here? We did not use any identity here. This identity was not used, so we can remove it. Now evaluate sine power 4 7x cosine 7x. This question is not new. We have done it in the question on algebraic substitutions. There are some questions from the old chapters here. So u equal to sine power 7x. You substitute. What's the derivative of sine? It is cosine with the number. The number gets adjusted. So it is, make a substitution, u equal to sine and the power is 4. So your answer will be sine power 5 and the number has to be found. Now the number is found by writing and substitution. U equal to sine 7x, du equal to 7 cosine 7x dx, cosine 7x dx equal to 1 over 7 du. So you'll get u power 4 into 1 over 7 du. Got this. Both cosine 7x and dx have to be transformed into du. It is 1 over 7 du, 1 over 7 will come out, you'll get u power 4 du. The answer is u power 5 divided by 5. 7 into 5 is 35. You'll write 1 over 35 u power 5. How much is u? U is equal to sine 7x. Now put back the value. It is sine power 5 as we had seen. Only this number 1 over 35 had to be fixed actually in this answer. And we have not used any identity in this topic, in this question. Now evaluate cosine power 5 into 17, cosine power 5 with the argument 17x and sine 17x. Now derivative of cosine is minus sine with the number. The derivative is sitting outside, so we have to make a substitution. u equal to cosine 17x. Now your answer will be cos power 5 plus 1, which is cos power 6. Now you have to fix the sign and the number. So let's make the substitution. U equal to cosine 17x, cosine 17x dx equal to minus 1 over 17 du. Now your integration will be, after substitution, u power 5 into bracket minus 1 over 17 into du. Get minus 1 over 17, integration of u power 5 is u power 6 divided by 6. Remember the minus sign, 17 into 6 is 102. Minus 1 over 102 u power 6. U equal to cosine 6x. 17x plus c. Yeah. Now again the answer can be checked by differentiation. Let's look at the answer in this case. Capital F of x equal to minus 1 over 102 cosine 6 argument 17x plus c. Derivative of c is 0. Now minus 1 over 102 is a number, it will come out, you will get 6 into cosine power 6 minus 1, which is cos power 5, and the minus we write here because the derivative of cosine is minus, and what is inside? 17. Write down the 17 and cosine goes to sine when you differentiate. Now 6 into minus 17 is minus 102, it will cancel with this minus and 102. You will be left with cosine power 5 17x into sine 17x. We saw this kind of integrations in previous chapters also. Now evaluate tan power 8 secant power 4 3x. Now we have to use one identity, secant square a minus tan square a equal to 1, which is equivalent to secant square a equal to 1 plus tan square. Now tan power 8 into secant power 4. Now the derivative of tangent is secant square. So one secant square will be consumed in the derivative with the number. The other secant square we have to convert into tangent square using this identity. So tan power 8 into secant power 2 plus 2, tan power 8, secant power 2, secant power 2, or we can say secant square, secant square. Now this middle secant square you convert to tangent square. It is 1 plus tan square. So you have tan power 8 into bracket 1 plus tan square into secant square. Now here you have a function whose argument is tangent, and the derivative of tangent is secant square with some number. That number will be fixed, do not worry about it. Now open the bracket, you have to make a substitution. After, in the next stage, you have 10 power 10 into, sorry, 10 power 10 3x plus 10 power 8 3x inside the bracket, and outside the bracket you have the derivative, which is secant square 3x. That 3 will get fixed. So make the substitution, u equal to tangent 3x. Yeah. Now secant square 3x is 1 over 3 du. Now put the substitution, you will get 10 power 10 plus 10 power 8 into secant square 3x dx. You will get u power 10 plus u power 8 1 by 3 du. 1 by 3 will come out, you will get u power 10 plus u power 8. Now you integrate, you will get u power 11 by 11 plus u power 9 by 9. Take 11 and 9 common, you will get 99. 9 here and 11 here, you will get 9 u power 11 plus 11 u power 9 over 297. Now put back the value of u is equal to tangent 3x. So it is, and this 99 into 3 is 297. So you'll get 1 over 297, 9 into 10 power 11 3x plus 11 into 10 power 9 3x. So you can put any power here instead of 8. The steps will remain the same, only numbers will change. You have to only worry about secant power 4 in this question. And we have used the same old rule, integration of u power n after making the substitution. And the answer can be checked by differentiation easily. Now evaluate secant cube 4x. Now again we'll use the same identity, secant square minus tan square a equal to 1, which is equivalent to tan square a equal to secant square a minus 1. Now secant square you can write it as, now here you have to use integration by parts. The other idea will not work here, so you have to be little bit careful. So you write secant 4x into secant square 4x. So u equal to secant 4x, dv equal to secant square 4x dx. Now you have to just remember or think during when you get the question before you. Now what's the rule of integration by part? U dv equal to uv minus integral v du. Now how much is u? U is equal to secant 4x, du equal to 4 secant 4x tan 4x dx. dv equal to secant square 4x dx. When you integrate on both the sides, you'll get v equal to 1 over 4 tan 4x. Now you put the value of u and v in this formula. You'll get integral I equal to u into v, which is outside, minus integral v du. Make the substitutions, you'll get 1 over 4 secant 4x tan 4x. Outside the integration, just copy it in several steps. Inside, what will happen? Inside you'll get 1 over 4 tan 4x into 4 secant 4x tan 4x. This 4 and 1 over 4 will cancel. You'll be left with secant 4x tan square x. Now this can be written as secant square x minus 1 in bracket into secant 4x. When you multiply this bracket, you'll get back your integral with the minus sign. So you'll get 1 over 4 secant 4x tan 4x minus I plus integral secant 4x. Now this minus I you can take this side, so your integration will become I equal to 1 by 2. Divide by 2, you'll get 1 by 8 secant 4x tan 4x plus half of integration of secant 4x. Now integration of secant 4x is, you have to remember this rule, integration of secant ax is 1 over a logarithm natural absolute value secant ax plus tan ax plus c. This rule has to be remembered as a basic rule. We can derive it, but we don't have to. Now you have to solve for I, because I equal to this expression plus this expression minus I. So 2I equal to this plus this divided by 2. So you'll get 1 by 8 instead of 1 by 4, and here you'll get half here. So your final answer is 1 by 8 secant 4x tan 4x plus 1 by 8 logarithm natural secant 4x plus tan 4x plus c. And again, it can be checked by differentiation in 5 or 6 steps. So this is your last question. We have discussed it before in the class. We'll discuss it again during the revision time, inshallah. Thank you. See you soon in the class.